Hey, all you crazy cats and kittens. I don't know if anyone watched Tiger King, but whew, goodness. Okay, so today we're going to talk about 12.1, and it's super similar to what we've been doing. Let me give you an example. So one of the hypothesis test questions in a previous section may have been something like, if I said, oh, well, the proportion of purple Skittles, let's say, in a little bag of Skittles is, I'm sorry, not mu. Let's say the proportion is 20%, okay? In other words, what they're saying is, when you open up a bag of Skittles, you should have 20% purples. And so you would do a null hypothesis that says, yep, the proportion is 20. And the alternative might be something like, no, I think there are more purples than that. So I'm going to go, it's more than 20. All right, so the difference between this is a single, one sample for a proportion. And so we would do stat, proportion, stat, and then one sample. But what we're doing in 12.1 is we're basically dealing with all the colors of the Skittles. So it's a total distribution. So I might say something like, okay, let's say there were 4 colors. So let's say we have purple, green, red, and yellow. And let's just pretend those are the only colors of Skittles. So instead of me just talking about the proportion of purple, I would talk about the proportion for each of them. So if I said that the purple still needed to be 20, and let's say the green was 10, and let's say we had 50% red, and then another 20% yellow, okay? So what the null hypothesis would be is that you open up a bag of Skittles, and your bag follows the given amount or the given percentages, and then you might challenge that and say, well, I think that it doesn't follow it. Okay, so this is basically how your null and your alternative will look. So so let's say that you open up your bag of Skittles, and for starters, let's say that you had, I don't know, 15, well, let's make it easy. Let's say you had 20 Skittles in the bag. So your total number of Skittles is 20 in the bag. So one thing you would want to know is, well, what should you expect that bag to have? And this is important. So you're going to have to identify your expected amount for many of your questions on the homework. Well, if I had 20 Skittles and I expect 20% to be purple, then that would be 4. I would expect 4 Skittles. How did I do that? I did my total number of Skittles, n, times the probability, which I think is actually the formula that you have on your notes. So n times the probability of the first one, so they call it P sub I. And this is your expected I. So this feels like a little Greekish or whatever. But this is basically how you're going to figure out each of these expected amounts. Out of 20 Skittles, if I should have 20% purple, that would be 4 as my expectation. I should have 10% green, so that would be 2. I should have 50% red, so that would be 10. I should have 20% yellow, that would be 4. This should add up to the original 20, which it does, okay? So this is my expected amount. Now, what I observed, let's say I open up my bag of Skittles and I actually count them, and I only had 3 purple, and I had 5 green, and 11 red, and 1 yellow. I think that adds up to 20 as well, doesn't it? Yeah. So these are the 2 columns that are important. So when you're using your StatCrunch, you have to say, well, this is what was observed. This is what actually happened. This is what was expected. Sometimes they'll give you the expected amount, and sometimes you have to figure it out yourself by taking the total in the sample times each probability for that particular one in order to get the expected. Now, the other thing that will throw you a little bit is oftentimes when you open the data in StatCrunch, they won't title this observed, they'll title it frequency. Okay, so, and I try to make a note of that in the Q's, but just something for you to see. And oftentimes they don't do the expected column at all. So once you figure up all these numbers, I would recommend that you create a column for yourself, title it expected, and that way you can do the StatCrunch the way that you want to. Because you really don't want to do this by hand. So what do you do in StatCrunch? Let me just erase this for a second. You're going to go to Stat, Goodness of Fit is what this is called. So it's how well it fits the distribution. And then from there, you're going to go chi-square test. Okay. Once you open that up, then you'll select what column would be the observed, what column would be the expected, and then hit compute, and it's going to give you your test statistic, which is the chi-square, and then the p-value, and it also gives a degrees of freedom, and I think there's one question that asks for that. The only other thing for 1 or 2 questions that you have to talk about are the requirements for this, and that's on in your notes under the block that says test statistic for goodness of fit test. It has 2 requirements. The first one is all expected frequencies are greater than or equal to 1, and the second one is no more than 20% of the expected frequencies are less than 5. And so I think that's for question 2. So make sure that you take a look at your notes for that. And that should be it. Talk to you later.